Hi, I am Geek, currently working at Hibernate. Today we'll be seeing how to write a scalable RDBMS solution, basically in Java. So it's more about how to write a scalable application in very few lines of code. So what's my previous ORM experience? So previously I was working in a company where they had a dedicated team which took care of pretty much everything for ORM framework. So they took care of all these things from connection management, codability, transaction management, and the last two is very important, which generally you can't find in any other open source or any paid ORM framework. That's security and scalability. So in scalability, you suppose DB is going at 90% of space. We weren't worried about that. The team will be taking care and they will be adding new more instances and it will be scaling of ease and we won't know where the user's data is. So how actually they scale? Maybe before 10 years, it was more of a vertical scaling era. You suppose you're having a bottleneck, then in case of DB, then you would just add few more SAT. So suppose 1 TB of data was there and there is no more space, then you would add another 2 or 3 more TB. But then you can't go maybe for after 10 TB or 11 TB, you can't just scale in the same system. So that's when horizontal scaling came into picture. So what's sharding? So sharding is nothing but the concept of splitting a huge data into chunks, into partitions, and placing those partitions in a separate, maybe in a separate physical database. So how they generally do that? Say suppose there is a user table, and say 1, 2, 3, 4, 5. These are the primary keys of the user table, and if suppose you want to split that table, you will just maybe add from range of 1 to 10. You will be storing rows in one table, 1 DB, and another after 10 plus rows in another DB. So suppose you are having a million record and you are having 10 TB, then you will just splitting million record by 10 and you will be storing those million by 10 record in every partition. So that's when horizontal scaling came into picture. That's how they scale. The only problem with this type of scaling is the user table is still as a logical unit the same table, but then it's residing on n number of DBs. Say suppose I want to merge a partition. Say suppose I want to merge these two partitions into one. The primary key should not get conflicted. That's the only concern. That's the only biggest problem while doing horizontal sharding. So that's the main bottleneck. So how they generally manage to create a primary key in a distributed DB. So they applied these solutions. Either they used to generate UUID. How many of you are aware of UUID? Have anyone used UUID? Nice. So it's generally a 128-bit unique ID. Very tough to create a same UUID by generating. You can generate n number of times, but you can't get a same UUID. It's a 128-bit. The only problem with UUID is it's 128-bit. Generally, the primary key will be of size 64-bit. So 128-bit is pretty much big, and you have a space penalty over it. And another concern is UUID is not it doesn't support natural ordering. Say suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then yeah, you could order it in 1, 2, 3, 4, 5, 7, 8, 9, 10. But then UUID you can't natural order it. So I can't run query like get start from where ID in range of 1 to greater than 10 or less than 10 or something like that. I can't do that. That's a big concern of UUID. Others Twitter's snowflake. So this one is an interesting concept. They internally use Zookeeper. So Zookeeper interns use Paxos, and it's a distributed system which its main purpose is to generate unique ID. And Another is Instagram. Instagram is the one approach which I like very much. So what they do is they initially create say a fixed number of logical shards, say 1000 or 2000 logical shards, and uh, in physical maybe they'll be having 4 physical shards. Say say suppose I'm having DB1, DB2, DB3. So each DB would be having some chunk of logical shards. Say suppose I am having 1000 logical shards. So 1000 by 3 logical shards. Say 333 logical shards will be there in this DB1, and each DB will be stored in a separate DB instance. So DB maybe is nothing but a schema. Not schema, actually it's a direct DB itself. So this is on DB1, maybe DB2, DB3. So in each DB I'll be having 333 schemas. So this DB will be having 330 schema, this DB will be having 330 schema. So like that. So if suppose I want to insert a user, say if the user's ID is 10. So there are some say generally they do modulo of the shard ID, and they will find the shard and they will place that row in that particular shard, either in one of the thousand shard. So suppose they are having a bottleneck, what they will do is that they will have one more DB4 and they will migrate few logical shards from here and here. So that's Instagram's approach. It's a nice approach. One bottleneck here is you have to create 2000 logical shards and you can't increase the logical shards once you have created that. So maybe suppose you are a startup and you want to create 2000 logical shards, it's a little pain. And the Flickr approach is very dumb and easy approach, and it's a scalable approach too. What they do is that they have 2 DBs. The 2 DBs, one DB will be generating primary keys in even number. The other DB will be generating primary keys in odd number. So it's not single point failure. You are having 2 systems. So if suppose one is going down, then you can always use the other to generate the primary key. So these are the ways in which you generally create a primary key. So there is one more approach that's called dynamic table. So that's what we do. So what we do is, instead of having a user table, a single logical user table, it will have user underscore the user ID itself. See user underscore 1, user underscore 2, user underscore 3. So in user underscore 1, I'll store all the user related information in the same DB. So main advantage is that you won't there is no external need for fencing. In the previous approaches, suppose you are having a single user table and there will be n number of users who will be storing that. Say suppose you want to create a application such as Gmail. So if suppose I am having a user mail table, and in the previous approaches what you would do is that user mail will have my 10,000 emails and your 10,000 emails and someone else 10,000 emails in same user table, and they have to write the query in such a way that suppose I am if Gmail is asking me for the last 50 mails, it should give me only my 50 mails and not some other user's 50 mails. So every query will be having a where query where user ID equal to, or where some primary key which is unique for me. So they have to add that query, and suppose they want to delete my mail and they have to add that where query. So if they didn't do, maybe suppose some SQL injection happened or something else, then it will affect the other users also. That you have to be very much concerned on the fencing part if suppose you are using the other solutions. So here you just avoid that. So that's dynamic table name concept. So I had when I started, I had these open source solutions which I could use, which I could depend on. So I had to pick up one from these open source solutions. So anyone used any of these open source solutions? Anyone? I guess everyone would have used Hibernate, but I don't know why they are not raising. You are not raising your hands. So Hibernate, it's very it has a very strong ORM mapper, and the one very unique thing about Hibernate is you don't write a table query, you don't write a create query. So it will write a create query, create query and the references for you. So and the querying is more of OOP state querying. You won't write select star from all these things. You just write get list of something like that. And they have their own caching solutions. The main concerns are these things. You don't have any control over DB. So in fact, suppose you are using any particular kind of DB, you can't write a specific query. Maybe MySQL will be having a specific kind of query, but you can't use that thing. And very much memory inefficient. If suppose you are using these using Hibernate in your production environment, then you would surely get the OOM because of this thing. And scalability issue as well. You can't shard. And actually they have a sharding library, but it still takes 2007 and it's still in beta version. So JOOQ and Cody DSL. So have you heard of active record? Super. So it's one kind of design pattern. It's more towards querying in a OOP style. So they have query builder. JOOQ and Query DSL both have query builder. Query builder is nothing but what do they? You can write queries in a OOP style. We can have it like that. And more control over DB. You can manage your DB's connections and all this stuff. And it's lightweight. The concern is pre-compiled query building. So here what they do is that before moving into the code, you have to tell the schema. So they will compile the schema and they will generate Java equivalent classes for the particular table. And if suppose you are having dynamic tables such as mine, say user underscore 1, user underscore 2, you can't address this solution. And JOOQ has a licensing issue, it's not completely free. So what's MyBatis? So MyBatis is a persistent framework which supports custom SQL code based on something. So one advantage is it supports primitive data type. You may be wondering why so much because of primitive data type. Say, suppose you are retrieving a long, capital long of 1000 records, and you are retrieving the same small long of 1000 records, it saves off of your space. And it do support frameworks such as Spring, Google Juice, and CDI. So we would come up with a sample scenario. So we would try to implement note keeping app by using MyBatis. So MyBatis has two things. One is MyBatis XML and MyBatis annotation. So these are the code structure would look like. So you would create your own models and DAO and the mappers. Mappers is nothing but maybe you can think as a alias for a query. So that's what mapper is, and the configuration. Okay. So in our application, there'll be three tables. One is B mapper. So the B mapper is the one where you store the nodes, and DB shared and user account. User account is the one which holds the n number of users who is using your app, and I tell you what shared is. Shared in turns will contain the reference, means it will contain where the user's data is. Say suppose I have created user 1, it will tell user 1's data resides on this table, this DB, like that. So as I said, so we'll be having three models. One is beam model. So model is nothing but it's a plain old beam which represents the table, which represents a normal table for this beam. So these would be the three beams. And if suppose I want to create a node, then I will be using this method create. So create in turn will create a will do an insert query. So in MyBatis XML, this is where the query resides on. So beam mapper. So each beam mapper, the entry is located here. Yeah. So the beam mappers is converted to the respective query. So the get instance will select star from the dynamic table name where ID is equal to. So this is the general syntax. So we'll run this application. If you want, you can download this application from my repository. It's in my GitHub. So okay, this is my GitHub link. Sorry, this is my GitHub link. If you want, you can download and you can run the thing. So this is our application. So this is how we store it. So maybe I'll be writing something. So you're giving it. It's more like a note keeping app. So this is a DB share. So Giridhar was one of the user in whom I was logged in previously. So this is how I do the sharding. So Giridhar will point to this DB. Maybe I can write some other DB. So whenever I'm logging in, it will look up where the user's data is, and it will point to the DB, and it will retrieve beam will be residing in this DB. So see, so beam 4 represents my sorry. Oh, sorry. So Giridhar's primary ID is 6. So the beam table will be of beam underscore 6. So this is the last insert at the equilibrium. So this is how we sharded. So MyBatis annotation, instead of having a mapper and a mapper's respective XML in two ways, and when you are developing, it's little pain that because every time you want to go to the XML and you have to change something, suppose there is some other changes, then you have to do the same changes in the mapper. So there are there is a two-way binding. So to avoid that, you can use annotation. So instead of having a separate XML, you could just annotate what the actual query is in the mapper itself. So that's MyBatis mapper. Sorry, MyBatis annotation. So that's how it is. So previously we had a bmapper XML. So instead of bmapper XML, we annotate what actually the these respective methods query on. So we'll just select this thing with me. So that's okay. So it's nice. We started something, but the problem with this approach as of now is we haven't dealt with any transactional problem. And if you could see Beam Devo, we are getting a connection and we are closing it. As of Java 7, this is a new try block. So instead of having a finally and closing it, you just use a single try to close it. So still, if suppose someone took the connection and didn't close the connection, then you would have memory leak problem. Still, we couldn't avoid that problem, and even we have issue with transaction. So if you could see the create instance use transaction. So I could get session of false means that auto commit is false. So I am committing the connection at the end. But the problem with this is DB share Devo is another mapper which will get a new connection. So suppose you want to create a proper transaction model, then you have to share the same connection, and you have to close it at one point, not in every point. So currently writing a transaction as of this model is you can't do that. Say you suppose you are having a table like three DOs like A, B, and C, and say A is the starting point and C is the ending point. So in code, A wouldn't know that that's the starting point. So I would have got a connection. A may think that I am the end point or I am the closing point. It will close the connection. Say after A, B came, and B, I would have shared the connection to B, but B may have thought that B is the last, and it would have closed the connection, which would result in null pointer exception to A. So you can't do that. If you want to manage a transaction, then you have to add that in application layer, where you know the whole stack is going to get done, so the endpoint will close the connection. So that's little tough as of now. So that's where CDI comes into picture. So what CDI? So have anyone used CDI? Had anyone heard of CDI? Okay. So CDI stands for context and dependency injection. So it's a Java standard for DA and AOP. So previously from JDK's 5 many open source solutions that came for addressing this AOP and DA concept. So the first one, I guess it's ActiveJ or some, I don't remember the name correctly. It's ActiveJ, I guess. AspectJ. Yeah, AspectJ. So actually, and then Spring came. So that's where Java got inspired, and they wrote their own standard for writing DA and AOP. And it's very simple. When compared to other Spring and other things, you have to do a lot of XML configuration, but here in CDI, you have to hardly write 2 lines of code, 2 lines of XML configuration. That's it. So what's dependency injection? So you could read, I just took it from Wikipedia. It's more like a, uh, delegating the instance task to some other framework layer. So it allows more decoupling. So generally, suppose you want to use a class, you'll always create a new instance and then you'll start on, instead of writing always new instance, you'll just tell create instance in annotated way. So that's how CDI do DI and aspect oriented programming. So POP is a program pattern that aims to increase modularity by allowing separation of cross-cutting concerns. Cross-cutting concerns is nothing but any concern which affects other concern, then we call it as a cross-cutting concern. One example for cross-cutting concern is logging. Logging, we add logging in n number of methods. So that's one cross-cutting concern. Or say in DB, suppose some operation will be, you are doing some operation in a table, then maybe the person who did the operation would be logged. So that logging process is the cross-cutting concern. So basically this address to separate the cross-cutting concern. So we'll see how CDI after we added CDI into our code, how actually the whole code had changed and how we could write the code in much better way. So previously we had like we got a connection and we in turn closed the connection. So here there is no SQL connection part. SQL connection part is handled internally by a AOP. So what you see at the top is one AOP. So this is on interceptor. So what it does is it's more like a version 2 of decorator pattern. Or it doesn't use proxy. So what it does is, so before calling, so I will see how the context interceptor is. So this is the method which should be called before calling any method in the BDO or any other class which annotates this context interceptor, which annotates this context of. So what it does is it's just you could do the process is the one which would call the actual method. So I could write anything before the process and I could write anything after the process. So the whole code becomes so simplified. Say suppose you want to have a single point to catch all the exceptions and to handle exceptions, you could do here. So this is this is where the connection closing and connection rollbacking would be happening. So this one this connection manager.clear will in turn close the connection. So since context interceptor is the one which is called at the start. So I could share or I could share the connections to a number of DOs without worrying about it. So this is one interceptor. So for the configuration is so simple. I'll just show the configuration. So this is the only configuration which it needs. So transaction interceptor is another interceptor which handles the transaction part. So here what we say is that transaction interceptor, this is the priority. So these are the interceptors which is coming at the last will be having the least priority or something like that. So context, if suppose you are annotating two interceptors, then first context interceptor will be called and then the transaction interceptor. So this is the transaction interceptor. So I just said I'm going to create a connection. Means I'm going to create a connection with the auto committers fault. So just these lines. So context interceptor will in turn close the connection or roll back the connection. So DA where DA comes. So previously, say, yeah. So previously I would have done db shared plus new db shared instance. So I'll just tell at inject. So it will in turn create a new instance, and since the db shared would be annotated as application scope. So that means that for this whole application there will be only one instance. So you no need to worry about single instance problem or blah 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 thing. So it will create just single instance and it will guarantee that. So I could have I could even have a factory, and maybe at test environment I would have some other configuration which says that db at inject of db share devo would create a test db share devo, and production it will be creating some other instance. So DA is basically at runtime it would create instance dynamically based on your configuration. So you can have now it's up to your imagination. You can have your own interceptors. Say I could have at async interceptor. So what at async interceptor would do maybe is like when you are calling this method, it will delegate the method to some other thread. So it will offload the work. So that much easy is when you add AOP to your code. So and authentication. Say suppose this method should be accessed only by the admin. So I could tell that at admin, something like that. So this is one example. So I will tell that at access role admin. Then the access is one interceptor. The access interceptor will actually check whether the given user is of role admin. So instead of writing everywhere in the code whether the given present context user is admin, you can just simply do an interceptor. So that's it. So that's it. So this is the code repo. Maybe you can go and download it and you can test it for yourself. And these are the links where I referenced it. So that's it. Any questions?
Go back to Git.
Any questions?
This is from Amazon. At the beginning, you mentioned like when there are multiple databases, when you try to merge two DBs, at the time you'll be getting some key conflicts.
Yeah.
So is it like basically keeping redundant data, or
no?
If you're just splitting up like partitions, then you don't have to worry about key conflict problems. But you said there will be, so it's like redundant data and different disk, right?
So you suppose you merge two partitions. Partitions could be merged and as well as split. So you suppose you are merging two partitions, then you will have a key conflict. Even if suppose you are not merging, the whole user table is actually in logical way it's actually a user table itself. In physically it's stored as a number of user tables. So still in logical way, user tables row represents a primary key.
Yeah, exactly. So all primary keys will be unique.
Yeah.
What I'm trying to say is like you said there will be a key conflict. So that's why I'm saying see,
yeah,
there will be conflict when you keep the same data in different DBs. Correct?
When in normal case, suppose you are having only one DB, how we create a key is that you will be having auto increment. Some you will be having a sequence and you will be auto incrementing. So if suppose you are having two DBs and each would be having two separate auto increment sequence. So I would get So suppose I am inserting a row in DB1, I get a key of value 1. And suppose I am inserting in DB2, I may get a key value of 1. So that's when the key conflict occurs. So,
I read some article like, have you heard about RAID, redundant array of indexes?
okay.
So all these storage utilization problems. Mostly companies will go for RAID where in hardware layers so they will just try to restrict that problem, then they can the load balancing problem. So are you sure Instagram using this technique like virtual balancing?
From I guess what actually RAID does is it's more like a master slave scenario. So RAID in turn copies the data in the master. It doesn't know whether it's a PSQL database engine or some other engine. So it just copies the DB's data. So that's what RAID does. So RAID doesn't address the scalability issue. RAID addresses the availability issue.
Okay, RAID address both availability and scalability. I guess I'm not wrong.
I think RAID addresses both scalability and availability.
Okay.
As you add, right, depending on the RAID level you have, scalability increases as well. If it's going to be just scripting, adding one more time increases your performance by test number.
So RAID generally copies the data, right? So if suppose I'm having a DB, so a hard disk HD1, so it copies HD1's content, right? That's what I get.
That depends on the RAID level you use. If you use mirror, if it's going to store it in one drive, it's going to replicate the same in the other drive as well.
Okay.
If you use scripting, it's going to store one block here and the other block there, which means you can do concurrent operations across drives. It all depends on the level of RAID we configure.
But suppose you are seeing in DB side, DB from DB's view, and I'm doing an insert. So even if I am RAID, I'm having RAID, so DB wouldn't know where the content is there. RAID may be giving you, maybe will be telling you where these rows are, means where the actual rows located in the file store. But still, what you do is that you copy the content. You just mirror the content. But say you're having a 1 lakh row and you're using RAID. Still, you're just using you're using it as a replication.
So probably what you can do.
Repeat this question for those who are listening overlaps.
Okay.
Okay. So this would be difficult.
So we will actually talk in detail about how it gets stored in the file system in the third talk, which is going to be about Postgres.
Okay.
But it all depends on the RAID level. RAID mirroring means replication. RAID stripping means concurrency. For databases, we either do RAID 5 or RAID 1.0, which is a hybrid model between mirroring and stripping. You will have at least 2 or 3 copies of the same block, but when you have a lot of drives, concurrency is there as well. So we will probably deal about how this is handled in Postgres in the third talk.
Okay. So any more questions?
I'm actually with you with the whole RAID goal.
Yeah.
Because even though you're talking about RAID 1.0, even if you have 10 hard drives, okay. So even though you have 10 hard drives, your storage is limited to the maximum size of one of the hard drives. So if I split it across 4 different drives, and even if I do the whole mirroring as well as the copying, the maximum size of my hard drive happens to be the maximum space I can use across the RAIDs, right?
Not really, because if you do a 1.0, right, and let's say you have 4 drives of 1 terabyte each, if you do
1 terabyte becomes the maximum.
No, not really. If you do a RAID 1.0, you can use 2 drives, because first you will do a RAID 1, which is 15, and then you will do a RAID 0 between those 2 drives. So let's say there are 4 drives, right? First 2 drives will be mirrored. These 2 drives will be mirrored. You can flip between these 2 drives, which means you have 2 terabytes.
So still RAID becomes a single, still it's a vertically scaled system. It's not horizontally scaled system. Maybe suppose you are having 4 hard disks, then still you are limiting to 4 terabytes. So suppose you want to scale 400 terabytes, but that can't be done in RAID. So that's the problem with RAID, right?
No, you just add more drives
Yeah, but you're multiplying. You're just constantly multiplying. You're not scaling up. So
Yeah,
you're
that's-
just stacking hard
that's
drives
what I'm
on
trying
top
to
of one.
For example, if you are making a query, where it will get executed? That's the problem. For example, if you are making a query, where it will get executed? That is the problem. Basically, write's purpose is for backup. For example, if there is any hard disk is failed, how we can recover the data? That is the only purpose.
No. So why do you need n arrays in the RAID then? People have
Yeah,
different-
because for example, they compute the checksum and they will store in a hard disk. So they can recover that part using that checksum.
Not really. Just wait. Give me a minute. Sorry.
I'm pretty sure the only question is, does RAID have master control?
No. See. So what we generally have is a RAID controller. So can you get it? Okay, there are two kinds of scaling, right? One is scaling horizontally and the other is scaling vertically. What vertically means, as you add more configuration to the system should be able to scale. We are talking in terms of one particular system. What horizontal scaling means, as you have had more nodes to the cluster, it should scale horizontally. RAID deals with vertical scaling. In the sense, there will be this RAID controller, and it will have lot of disk. Let's say there are 6 disks here, and we have 6 1 terabyte disks. So if that is the case, I can come up with various RAID formations. Okay, what I can do is I can say that, oh, you know what, I can guarantee the quality of disk I have. I need very high performance. What do? I don't replicate. I just mirror. I just flip things apart. So let's say if there are 6 blocks coming in, I can write to all these 6 drives in parallel. In the sense, you tend to get the maximum performance out of the disk, but you don't get any replication. Which means even if one drive fails, the entire cluster will be down or that data will be lost. So what can we do better? So can we do something like 1-0 in the sense, let's say I'm going to club these 2 drives together and mirror between them. In the sense, if you write one block to this club, it will be returned to both the disks. If that happens, if one of these disks goes down, others will be there and I can insert a new disk and replicate it. So in this case, we get the power of 3 disks instead of 6 actual disks, which means I can use up to 3 terabytes. So what about the highest level of fault tolerance? My disk is of low quality and I need a higher factor of replication. Let's say I'm going to configure everything in RAID 0 or mirroring. If that is the case, I will have only one group here, which means a write to this will have to happen in all the 6 drives here, which means I will get only the bandwidth of one drive, which is 1 terabyte. So it all depends on how we configure the RAID systems.
But you can't add one more drive.
Yeah. And that increases the scalability depending on your RAID level. If it is just going to be mirroring of all the disks, it doesn't improve the scalability. If you are going to strip it, then it does.
So if you have 6 strip disks, I cannot add a 7th drive or an 8th drive and have the 6 stripes. Again.
You cannot repartition things off, but you can add it to the array, which means new arrays will also be returned to the 7th or 8th disk. If you want to rebalance it, it highly depends on the vendor you use.
So depending upon either in software RAID or hardware RAID,
Yeah.
you put in a new controller and give it a new RAID array, or you configure a new RAID array in software for the new drive which you have.
Yes. It all depends on the setup basically.
So you answered the original question, which was
like what he was trying to say, why worry about all this? I will let the database engine just go in a very scalable model, and I let the, whatever, I don't have to say database 1 sits on hard drive 1, database 2 sits on hard drive 2. I just let the RAID controller do whatever it wants. And I'll hold on to my scalability at the database level and not worry about, this. Which was his original question.
Yeah, that depends on the scale, right? If it is going to be 1 terabyte, I can simply put 8 disk and not worry about scalability. If it is going to be 40 terabytes, I need to think about scaling horizontally across machines. That all depends on the volume of data you handle. If it is going to be 100 GB or so, right? Why do I need to worry about horizontal scaling and then replication and all those things?
So, but do you see, coming back to the question, his original question was, if like your example, if there's 100 GB of data, do I put tables 1 to 100, do I chunk my tables, or do I just keep my database as one single engine and let the RAID controller take care of however it wants to hold it? Yes. Or do I do the chunking at the records level and I say, okay, RAID 1 takes this, RAID hard drive 2 takes this, and that can go chunking. Is that what he was trying to say, or did I just the whole thing? That's what you're trying to say. Okay, so yeah, so that was his question. So my thing is, how would you do it if you wanted to be if you wanted to scale at database level?
Okay, there are two modes of scalability here as well. Because, so let's say that you have a single very big table, right? Let's say 1 billion records or so. If you put an index on the table, it's not going to help anyway because it will have to scan the index and it will take time. That is when people go for partitioning or sharding. If the data is very low and if you could come up with a good sharding mechanism, it would help. But you can have multiple shards on the same machine as well. It is not necessary that you should put it into other machines. You're just helping the index to locate the row quite easily. For a medium-sized database, I think horizontal scaling will introduce more complexity into the picture because of the network bandwidth and all those kind of things. There's of course this cap theorem which slows down the entire database for OLTP related operations. So it all depends on the scale, right? If it's less than 100 GB or 200 GB or so, you probably don't need to scale horizontally. You can still go ahead with vertical scaling. But let's say of the scale of Facebook or something, so Facebook or Twitter, you should start scaling horizontally, which means partition.
Makes sense.
Maybe I should have renamed my topic as high scalable RDBMS application, plus scalable RDBMS application. Sorry. That's it. Thank you.
Thank you, Giridhar. Let's disperse and come back promptly at 7:05. And the next talk will be effective use of JDBI by Manikanda. And let's keep all the